Hello, welcome to lesson 15. In this lesson, we are going to look at the terrestrial telescope, and then we shall also look at some examples on astronomical telescopes, that is, calculation examples. Let's begin by looking at the terrestrial telescope. So a terrestrial telescope is also a refracting telescope, which is got by modifying an astronomical refracting telescope. It consists of an intermediate erecting lens of focal length f, which is placed between the objective and the eyepiece. So we place an erecting telescope between the objective and the eyepiece of the astronomical telescope. So the erecting lens, that is this erecting lens, should be at a distance 2f after the principal focus of the objective. It must be a distance 2f after the principal focus of the objective and a distance 2f before the principal focus of the eyepiece, as we shall see in the illustration. The objective lens forms a real inverted image of a distant object at its principal focus f0, and this acts as a real object for the erecting lens, which forms a real erect image of the same size as the inverted image by the objective. Let's see. So this is the erecting lens placed between the objective and the eyepiece, and is placed a distance. So the distance from the erecting lens up to the principal focus of the objective is 2f, and also the distance from the erecting lens up to the principal focus of the eyepiece is also 2f. So the objective forms an intermediate image which is real, and that real image acts as the object for the erecting lens, and then it is going to form a final an image here, which is this image is going to be real and upright erect. Then after that, this acts as the image, so the object for the eyepiece, and the final image is going to be at infinity, but it's going to be a real image at infinity. Let's look at the advantage of a terrestrial telescope. Now, before I talk about the advantage, I need to emphasize this, that for all these telescopes, it is very important for you to know how to draw the ray diagrams, because they'll be necessary for you in the examinations. Usually they ask for those ray diagrams, and also the angular magnification, derived with the angular magnification, then the advantages and disadvantages, and then the calculations, as we are going to be seeing. Let's look at the advantages of the terrestrial telescope. One, we need to know that, as you have seen, the final image is erect. It forms an erect final image. Then the disadvantage of the terrestrial telescope is that it is bulky, as we have seen the length, because we have to place another lens in between. So it is bulky since its length is increased by 4f compared to an astronomical telescope. So it is quite bulky. And then also it reduces the intensity of light emerging through the eyepiece, because you know that at each refracting face or each refracting surface, there is always going to be loss of intensity of light. So there is a reduction in the intensity of light. Let's look at the examples. Let's look at some examples on astronomical telescopes. I have this question. An astronomical telescope has an objective and an eyepiece of focal length 100 centimeters and 5 centimeters. Remember, you're looking at astronomical telescope. Find the angular magnification of the telescope if arranged in normal adjustment. Then if the lens is arranged in such a way that the final image is formed at 25 centimeters from the eyepiece, calculate the angular magnification of the telescope in this setting, and then the separation of the objective from the eyepiece in this setting. So we have two settings here. Let's first look at when it is in normal adjustment, then after we shall look at this when the final image is at infinity. That is when not in normal adjustment. So when the final image is at a near point. Sorry. So let's begin by looking at the first part. When it is in normal adjustment, we want to get the magnifying power. Remember, we had already derived the formula for the magnifying power. M is F naught over Fe in normal adjustment. So you can just use the formula where F naught is 100 and Fe is 5. So if you divide 100 by 5, we shall get 20 as the magnifying power or the angular magnification. Magnifying power is the same as angular magnification. Let's look at when the final image is at a near point. They also want us to get the angular magnification of the magnifying power. So here we shall still borrow the formula that we derived. That is M is equal to F naught over Fe into brackets 1 plus Fe over D, where F naught is 100, Fe is 5, and D is 25. So when we work out that, we get our M as 24. So it means that the angular magnification is 24. Let's look at the second part. They want us to get the separation of the objective from the eyepiece. Remember, this is when the final image is at a near point. So it means that the separation is going to be F naught plus U, where U is actually the distance from the intermediate image up to the eyepiece. So it means that we need to get the U and then add it plus F naught. So the U is what we need to have. So this is the illustration. So we have this F naught, which is 100, and then this U, which we need to get in order to get the distance from this point up to that point, from the objective up to the eyepiece. Now, but remember that the final image is 25 centimeters from the eyepiece. So it means I can consider the action of the eyepiece. And so if I consider the action of the eyepiece, the V is negative 25, because it is a virtual image, and then the Fe is 5 centimeters. So I can get the U, considering the eyepiece. So using the formula 1 over F is equal to 1 over U plus 1 over V, I can get my U as 3.57 centimeters. Then when I add here, I'll get my separation as 100 plus 3.57 centimeters, which will give me 103.57 centimeters. That is going to be the separation of the lens, of the objective and eyepiece lens. Let's look at this question 2. The objective of an astronomical telescope in normal adjustment has a diameter of 12 and the focal length is 8 centimeters. If the eyepiece has a focal length of 5 centimeters, find, Roman 1, the magnifying power of the telescope in this setting, and then the position of the eye ring. So here we are going to apply the idea of the eye ring and also get the magnifying power. But remember, let's start by getting the magnifying power in this setting. This is a setting which is normal adjustment. So if it is normal adjustment, we know that M is equal to F naught over Fe. So these are the questions. Let's look at even these other questions. And they also want us to get calculate the diameter of the eye ring, and then they also want us to calculate the also state the advantage of placing the eye at the eye ring. So that's the question. Now let's look at the solution. First of all, they want us to get the magnifying power m, which is f naught over fe. Then shall just substitute. F naught is 80, and then fe is 5. So that will give us 80 divided by 5, which is 16. So that is going to be the magnifying power of that telescope. Then the position of the eye ring. So the position of the eye ring, we know the formula. We want to get V. That is when we consider the action of the eye piece. So the U is going to be, remember that when you consider the action of the eye piece, the U becomes the F naught plus the Fe, and then the F becomes the Fe, and so we can get the V. So we shall get the V using the formula 1 over F is equal to 1 over U plus 1 over V, and V is going to be 5.3125. That will be the position of the eye ring. Then they want us to get the diameter of the eye ring. Remember the formula, diameter of the objective over diameter of the eye ring is equal to M, which is F naught over Fe. So that's the formula we shall use. So diameter of the objective over diameter of the eye ring is equal to F naught over Fe. Diameter of the objective has been given as 12 centimeters, and then F naught, we have it 80, Fe is 5, so we can get diameter of the eye ring, and that is going to give us 1.125 centimeters. That will be the diameter of the eye ring. Then they want us to also state the advantage of placing the eye at the eye ring. So the advantage of placing the eye at the eye ring is that the eye placed at the eye ring has a wide field of view. It has a wide field of view, since most of the light entering the objective passes through the eye ring. Since most of the light passing through the objective passes through the eye ring. So that is the advantage. Yeah, thank you for your attention. We meet in the next lesson.